Good day everyone, I am Keter Gaida, ID123, and today I will be teaching you FNDMATH LQ4 problem number 3. So to start, I hope you've watched the previous video, problems number 1 and 2, so that you may have a deeper understanding of what we're doing here today. So, we will as we did in problem number 2, we will do a reference triangle. We will try to draw a reference triangle. Sorry for my handwriting, it's not straight, but it does the trick. So we know that the range of the arc sine function, or sine raised to -1, is included in negative pi over 2, sorry, this pi, 2 pi over 2. Okay, so that means that the arc sine function exists in quadrant 1 and quadrant 4, because this is pi over 2 and this is negative pi over 2, it's just 270 degrees. But since we have a positive value, that means the arc sine value bears a positive value. That means it exists within the first quadrant, because sine is positive in the first quadrant, right? Alright. So with that out of the way, we can say that the reference triangle exists in the first quadrant, so we can try to draw it like here. This. Then we get theta. So a sine of theta, so we know that sine, inverse sine of a certain value is equal to theta, or an angle. That means that this theta must equal to this value, right? Inverse sine of that value, 24 over 25. We know that sine theta is just opposite over adjacent. So that means the opposite side is 24. So opposite side to the angle theta, 24, and the hypotenuse side is 25. Opposite over hypotenuse, I mean. Sorry for the confusion. Okay, sorry for my allergies. So guys, make sure to drink your medicine. So now we can try to solve for the adjacent side of the triangle by the Pythagorean theorem. So we get a squared plus b squared is equal to c squared. We all have b squared and c squared. Let's just try to substitute it. 24 squared plus a squared. So moving on to the other side, we can say that the sum of the squares of these of the difference of the squares of these two, 25 squared minus 24 squared, is just equal to the square root of 49, doing quick math, and it's just equal to 7. So we can say that the adjacent side is equal to 7. So we just completed the triangle, right? Because we're going to be using this reference triangle later on, as we did in the second problem. So if you're still watching and you haven't yet watched the second problem, I highly encourage you to do so that you may understand more why are we doing this. So we will assign theta to inverse sine of 24 over 25 is 4 na. Okay. Sorry, it looks like a 9. I just removing it so that you won't get confused. So yeah, so moving on, we can simplify it to cosine squared of 1/2 times theta. So this is a half angle identity. So if you remember from your previous LQs, that the half angle identity of cosine squared theta is just equal to 1 plus cosine of 2 theta over 2, right? So substituting it, since cosine squared, we have theta over 2, we're just gonna do it to the other side, plus cosine 2 times theta over 2 over all of that over 2. So we notice that These two cancel out. So in reality, we're just left with 1 plus cosine theta over 2, right? So we can also solve for the triangle now. So this triangle, since cosine theta is just equal to the adjacent side over the hypotenuse, so the adjacent is 7. That's why we solve for the adjacent side. 7 over hypotenuse of 25, right? So substituting this back here, we can now solve it for 1 plus 7 over 25 over 2. Now we can solve it. So 25 over 25 plus 7 over 25 over 2, just algebra, fractions, sum of a whole fraction and improper fraction. No, it's a fraction. Sorry, it's not improper fraction. A whole fraction and a fraction. So yeah, you get the LCD, and yeah, you basically tackled it in algebra. So we get 32 over 25 over 2. That's just equal to 32 over 25 times 1/2 is just equal to 32 over 50. So we can further simplify it. Sorry, it's a long way here. 32 over 50 is just equal to it's 16, right? 16 over 25. So that's the final answer. 16 over 25. Wait, I'm gonna try to fix it. Sorry for my poor handwriting and penmanship. 25. Alright? So to recap, what we did first is assign a reference triangle so that we may know what values lie within that specific theta, right? So now that we have a reference triangle, we've substituted theta for the inverse sine function because, remember, inverse sine of a specific value is just equal to theta, or an angle, right? So since we don't know the value of theta, we're just gonna assign this whole term to the value of theta, right? Because we don't know if it's 45 degrees, if it's 30 degrees, or whatever. What we only know is the specific value it bears, right? So now moving on. So since we've substituted theta for the inverse sine of 24 over 25, we get cosine squared theta over 2, which is half angle formula, right? So we know for the half angle formula that cosine squared theta over 2 is just equal to this this equation here, 1 plus cosine 2 theta over 2. Then we simply evaluated the value. These two cancel out, and 1 plus cosine theta, and solving for cosine theta, we get the adjacent over hypotenuse side of this triangle. So that's why we created this triangle, right? If you're still wondering. So it's just 7 over 25, 1 plus 7 over 25, and yeah, basically it's just equal to this one, right? So we may take a screenshot, or simply try to do this on your own without any help. So this is just the main problem. Try to solve it on your own and see how we've got to this answer. So thank you guys for watching, and I hope to see you more on our next problems. Subscribe to SYNTube and scan the QR code to book us tutorial sessions. Thank you and have a good day.